Hello, dear students, friends, listeners. I'm sure you're all doing good, and welcome to our second class, chemistry class. So, yesterday I have given you a home assignment, and I'm sure you have tried. So, let's solve this together. So, dear students, balancing chemical equation is like a game. It's very interesting. Not just the balancing chemical equation, but the chemical reactions, whatever we will study in the chemistry portion for class 10 are all very important, and it's very interesting. And together it will be very fun. So the home assignment that I have given you yesterday, let's solve together. Clear? So let me just read out the question for the listeners as well. The question that I gave was to balance the chemical equation for sodium plus water, H2O, sodium hydroxide, and hydrogen gas in the reactant. So in the reactant, we have sodium hydroxide and hydrogen gas. Okay, so students, I have given S here because S signifies solid. Clear? Solid, S-O-L-I-D. And the letter L, H2O, you all know it's a water. So L signifies here liquid. Clear? And in sodium hydroxide, NaOH, I have given in bracket AQ. AQ means aqueous solution. AQUEOUS, aqueous solution. That means solution in water. Clear? Like salt and water together, we'll call it as aqueous solution. So NaOH is an example for that, AQ. And H2 here is the hydrogen gas. For gas, we have given the letter G. So I'm sure you are clear with this. So now let's all check together whether this equation is balanced or not. And if it is not balanced, we'll apply the step that I have given yesterday and we'll balance this equation. So the first step, what we will do is, we'll write the chemical equation here. And the first step is to draw a box around each formula. So you draw a box in the sodium here, in water, in sodium hydroxide, and in hydrogen gas. So the second step is to list the number of elements. So whatever elements are here, we will list down. The second step. For second step, you have to draw three boxes here. So the first one will be for number of elements. The second one will be reactant, that means on the left hand side. And the third one will be for the product, that will be on the right hand side. So now everyone, let's say how many elements are here in this equation. Okay, so we can see sodium, we can see hydrogen, and we can see oxygen here. So we don't see any other elements apart from sodium, hydrogen, and oxygen. So let's list the elements here. Sodium, Na. Na is the chemical formula for sodium. Hydrogen, H is the hydrogen, and O is the oxygen. So now let's count how many sodium are there and how many sodium are there on the left hand side and on the product side, that is right hand side. So only one, we have only one sodium. We have only one sodium on the product. Now let's see how many hydrogen are there on the left hand side, 2. Now you see here, students, everyone on the product side, the hydrogen that we see is 1 plus 2. So we have 3. Altogether, we get to see 3 hydrogen. In NaOH, there is 1 hydrogen. And in H2, we have 2 hydrogen. That means overall, in the reactant side, we have 3 hydrogen. So from here itself, we know that this is a skeletal equation, chemical equation. That means this is not balanced. Oxygen, we have 1 here, 1 on the right hand side, 1 on the left hand side. So this chemical equation is not balanced. We'll go ahead, we'll go balance this equation. So it's like I have said, it's like a game, okay? It's like a game until unless it is balanced, until unless we get an equal number on both the left hand side and the right hand side, we will add numbers. We'll multiply the numbers, and once they are all balanced, that means we got the answer. Clear? So since sodium is 1, 1, this is good. Oxygen, 1, 1, it is good. But here when we see hydrogen, we see 2 on the left-hand side, but on the right-hand side, we see 3 hydrogen. That means 1 plus 2, we have 3 hydrogen. So instead of thinking like too much about this one, how do we balance this one? I'll give you one, when you face this kind of situation, I'll give you one idea, that is, whatever odd number you have, you try to convert it into even. Odd number, you try to convert it into even. Because if we have all the even number, that means we'll be able to balance it very easily. So here the odd number that we see is 1. So 1, if, okay, this is 1. So if I multiply, now let's start balancing. If I multiply 1 into 1, that means the answer is same. I'm going to get 3. So what I'll do is I'll go ahead and multiply with 2. That means 1 into 2, 2, 2 plus 2, that means I get 4 hydrogen. And over here I have 2. So these 2, I can make it 4 by just multiplying it with 4. 2. By just multiplying it with 2, I can get it 4. That means I have 4, 4. So what we'll do is that since I have multiplied this with 2, I'll go ahead and write this over here before the formula. So that means I have 2 hydrogen here, students, and 2 hydrogen on the other side. That means I have all together 4 hydrogen. So since this is 4 hydrogen, now in order to balance this, even on the left-hand side, I have added another 2 hydrogen before the formula. So that makes our hydrogen 4, 4, which is balanced. So our hydrogen is balanced, but look here. While we have balancing our hydrogen, oxygen is already balanced automatically. Because look here, we have 2, this means 2 times hydrogen, 2 times oxygen. So that means our oxygen is also 2 now by default. Our oxygen here on the right-hand side is also 2. And our sodium on the right-hand side is 2, but our sodium on the left-hand side is still 1. So it's very simple. Since on the right-hand side is 2, I'll multiply it with 2. Now 2, 2, it is equal. So what I'll do is, since I have added 2 here, whenever I'm writing 2 here, I'll go ahead and put this 2 before the formula. So now let's check. 2 sodium on the left-hand side, right-hand side, 4 hydrogen on the left-hand side, 4 hydrogen on the right-hand side, oxygen 2, 2. So that makes this equation balanced. So we can say that this equation obeys the law of conservation of mass. So no elements here, the number of atoms are not lost. Whatever we have on the left-hand side is equal to the right-hand side. So now this equation is already balanced. So the right answer for this equation would be 2 sodium on the reactant. On the left-hand side, it will be 2 sodium, 2 Na, 2 H2O. And on the reactant side, the product, we have 2 NaOH plus H2. Okay? So everyone, please note down. Okay. So if you are done with this, noting down this chemical equation, yesterday I have given you different types of reaction. So today we'll study all the types of reaction one by one in detail. Okay? So the first type of reaction that we'll study is a combination reaction. Combination reaction, to combine. The word itself says it all, to combine. Combination reaction. So the first type of reaction that we'll be studying is combination reaction. Combination reaction. So I'll write the definition here. The proper definition for this reaction would be 2 or more elements combine to form a simple substance. So students, I'll give you an example. Just A plus B gives AB. This is just an example. Or I'll give you a boy and a girl. They were in love, they got married. So after getting married, they become a parent. Boy and a girl, now they're husband and wife, so now they become a parent. So A and B join together, they become AB. So this is simply an example of combination reaction. So the chemical reaction for this combination reaction, I'll give you carbon, C carbon plus oxygen gives carbon dioxide. Clear? In this type of equation, it is already balanced. The second example that I'll give for combination reaction would be magnesium and oxygen together. We have magnesium oxide. And here, this equation is not balanced because we have 2 oxygen here and 1 oxygen here. So we'll go balance this one out over here. So we have 2 magnesium, 2 oxygen, 2 times magnesium and oxygen. So this is an example of combination reaction. And we have many examples. Whatever equation that we get to see combining and giving an answer of a compound. Like a single elements combining to give a compounds are an example of a combination reaction. Clear? And now before we start the next reaction, that is decomposition reaction, we will study exothermic and endothermic reaction. Exothermic and endothermic reaction. So first we'll start with exothermic reaction. Exothermic reaction. Exothermic reaction. Those reactions which involve releasing of energy in the form of heat. Releasing, this word you have to keep in mind. This itself is a definition. Releasing energy in the form of heat. So in this reaction, what you'll see is there will be a releasing of energy, and that will be in the form of heat. I'll give you an example here that will be calcium oxide, CaO, calcium oxide plus water, you'll get calcium hydroxide and heat. This one, now you might be confused, but this is very common example. Calcium oxide, CaO, calcium oxide. The common name is quicklime, L-I-M-E, quicklime. And then the chemical name is calcium oxide. Calcium oxide is the chemical name. And the local name would be tuna. Okay, tuna. It is white in color. The local name tuna. Local name for calcium oxide is tuna. I'm sure you all have heard and you have all seen tuna. It is not new. And H2O, you all know it's a water. So what will happen if you add this? If you react water and tuna together or a lime together. If you add water in this lime, what you will get? We will get slacked lime. S-L-A-K-E-D-L-I-M-E. Slacked lime is what you will get. On mixing quicklime with water, quicklime is the common name, quicklime is the common name, and the chemical name is calcium oxide. CaO is calcium oxide, and the local name is tuna. Okay? And so quicklime on addition with water will get slacklime. And now you can try this experiment at home. Just in a glass of water, you put a lime and you add some water. What you will get to see is that you'll hear a hissing sound. H-I observation. You'll observe the hissing sound. Hissing sound. Sometimes in exam they ask you what kind of reaction, in what kind of reaction you get to hear a hissing sound. Then you can simply give answer when we react calcium oxide with water, we get to hear a hissing sound. Hissing sound. So when the products that we get from here is slacklime, that is calcium hydroxide. And the other things that we get to see is we'll get to see that heat will be released. If you just touch the glass, it will be warm. Clear? So that means this is releasing the energy in the form of heat. So this is coming under exothermic reaction. And if you might be wondering what is slacklime, slacklime is CaOH2, calcium hydroxide. And where do we use this slacklime? Slacklime we use for whitewashing of house. Uses CaOH2 is the slacklime, and we use this slacklime in whitewashing of house. So this is very important use. Uses of slacklime is in whitewashing of house. So from here you can write many questions. Write the chemical reaction of this is an example of exothermic reaction, and this can also be an example of combination reaction because we are combining two things to give this slacklime. Okay, so students, exothermic reaction here, I have given an example here, and this example is not just for exothermic, but you can also use this equation for combination reaction. Clear? And they can also ask you write the chemical reaction that involve quicklime or write a chemical reaction involving slacklime. Then you have to write this equation. And from here they can simply ask you write one important uses of calcium hydroxide. Then you can write whitewashing of house, or they can ask you write the important use of slacklime. And the sound, the observation. In chemical reaction, the one important thing is observation. So what we get to hear is a hissing sound. So keep this in mind. A hissing sound is observed when we add calcium oxide and water. So please note this down. Now the next reaction that we are going to study is endothermic. Okay? So before we start the endothermic, write this equation, write the use of this slacklime, and write the observation, that is a hissing sound. And also don't forget to write this heat, okay, because we are writing an example of exothermic. So don't forget to write this heat, releasing of heat. Okay, so now let's go to next reaction, that is endothermic reaction. Okay, so we are done with exothermic, and now here's endothermic reaction. So what is endothermic reaction? It is absorbing energy in the form of heat. In the form of heat. So it's an opposite of what we studied earlier. Earlier in the observation, we get to see that heat was releasing, right? Now here what we are getting to see is we are absorbing energy in the form of heat to get the results. Very simple. We have very practical example, many examples for this. To cook, what do we need? What do we need? We need heat. To cook food, we need heat. Example, cooking food. Or another example, what I can give you is ice. Ice in a solid form, if you don't have to do anything, but if the temperature is warm, nature itself will absorb the heat and now it will convert to water in a liquid form. Solid to liquid form. Ice to water, liquid form. Clear? So, chemical reaction, I will give you, okay, students please note this one, the definition for endothermic and the common example to let you understand cooking food or conversion of solid to liquid. Clear? So, I'll give you an example of chemical reaction for this endothermic, but before that, please note this one down. Okay, so let's take example nitrogen and oxygen. Clear, students? This is nitrogen, I'll write down here, and this is oxygen. Nitrogen and oxygen together, and then what is needed? Absorbing heat. For heat, you can just write this one. This one implies heating, or you can just write HEAT. This denotes that we are absorbing heat to give the result. So now we have nitrogen oxide. But as I have said in the first class, in chemical equation, everything we need to balance. So on the left side we have 2 nitrogen, on the left side we have 2 oxygen. But here we have only 1 nitrogen, 1 oxygen, 1 short. So just simple, just 2, I have put 2 over here, so that means it is 2 times nitrogen, 2 times oxygen. So this is a balanced chemical equation. So this one, the given equation here is example of exothermic reaction because I have written heat here. This nitrogen and oxygen are absorbing heat to give nitrogen oxide. Clear? Let me repeat it. Nitrogen and oxygen are absorbing heat to give nitrogen oxide. So that means this is an endothermic reaction. Clear? So the next type of reaction that we will study would be decomposition reaction. So students, have you noted down this one? Please note this one. Okay. Now the next type of reaction which we will study is decomposition reaction. Decomposition reaction. Here, before I give you definition, the very word decomposition means breaking down. Breaking down of one compound into 2 or more simple substances. So decomposition reaction is defined as breaking down of one compound into 2 or more simple substances. So this, if you just read this definition, breaking down of one compound into 2 or more simple substances, this is just opposite of combination. In combination, it was like A plus B gives AB. Now AB is breaking down to give AB is breaking down to give A and B. So this is just opposite of combination. In combination, A plus B give AB, but in decomposition, one compound is breaking down to give 2 or more. It's splitting. Clear? So decomposition reaction is further divided into 3 types. This decomposition reaction, we have 3 types. So the first type is thermal decomposition. Thermal decomposition. Thermal decomposition. The second one is electrolysis or electric decomposition. Third would be photolysis. Photolysis. So this is important. These are the three types of decomposition reaction. Now, decomposition says to break one compound to give two or more simple substance. How do we break the compound? There will be a way to break a single compound. So one way is, the first type would be thermal. Thermal means heat. The meaning of thermal means heat. By applying a normal heat, we can break the compound. Clear? The second one is electrolysis. Electrolysis, electro means electric current. EC. I will just write in a short form so that you understand. Yeah. EC. EC means electric current. So we are applying electric current to break the compound. Clear? The third one is photolysis. Photo means light. Photo means, so the third one here is we are going to use just the natural sunlight to break the compound. So how do we break the compound? Either we'll use heat, or either we'll apply electric current, or either we'll use sunlight, natural light, to break the compound. So first, let's see thermal decomposition, and I'll give you an example for that. Thermal decomposition, you can write when decomposition reaction is carried out with the help of heat. You can just write like this. Let's keep it simple, students. So when decomposition reaction is carried out with the help of heat, it is known as thermal decomposition. So example, let's use the same example that we have. I'll give you a very common practical example for this one. Let's use water. Water, if you apply a normal heat, what will happen? It will break down into hydrogen and oxygen. Now you just imagine, if you heat the water for a long time, what will happen? You'll get the water, no, you'll see gases coming out. What type of gases? Hydrogen and oxygen. That means water is already breaking down. So this water has already been decomposed into hydrogen and oxygen by passing with the help of heat. Clear? Now, if you are clear with this one, we'll go to the next type of decomposition reaction, which is electrolysis. Electrolysis. Even this one, to make it very simple for you, electrolysis decomposition reaction, we can use example of water. These days, we have an electric kettle where we boil water with the help of electric current. If you do it for a long time, what you will see is, you will see gases coming out. So this one will take another practical example, H2O, and then we'll pass electric current, EC, electric current, we'll get hydrogen and oxygen. Clear? So we'll balance this one. So this is an example of electrolysis decomposition. And for this, you have to write, the definition would be the same thing, when decomposition reaction is carried out with the help of electric current. An example, you can give water breaking down with the help of passing electric current. Example, electric kettle. Clear at home? Please note this one down. Now we have the last one, that is last type of decomposition reaction, that is photolysis decomposition reaction, that is breaking down with the help of sunlight. So the definition would be very simple. It is when decomposition reaction is reaction is carried out with the help of sunlight. So this means we are going to utilize, or we are going to utilize sunlight to break the compound. So one important thing and one important example and equation that I'll give for this one is silver. Silver, you all know what is silver. Silver, we don't just get it silver. AgCl. So Ag here is the chemical formula for silver. In chemistry, we never write SILVER while writing the formula. Ag is the chemical formula for silver. And here we have silver chloride, Cl, AgCl. AgCl, when we just keep it in sunlight, what we will notice? This Cl breaks. Okay, so by passing sunlight, we'll get silver and chlorine will be separated. Clear? So chlorine will be passed out in the form of gas. So now we get a silver. Before it was AgCl, but with the help of sunlight, now we are able to obtain the silver. And Cl is gone in the form of gas. And why I have written Cl2 here? Because Cl2, chlorine is a non-metal. It is a gas. So whenever we are writing chlorine alone, it needs a backup, Cl2. So write Cl2 here. So this is the example for photolysis decomposition. So there are three types of decomposition reaction. All the three today we have discussed, and I have given examples. So students, please note this one down, go through it. And tomorrow we'll start with another type of reaction, that is displacement and double displacement reaction. So thank you everyone. See you tomorrow.